Imagine a society where the adults gather, like twice a month, and they drink 89 proof rum.
And we are not talking about a casual cocktail here.
No, definitely not. We're talking about drinking until they literally pass out. For days at a time.
Right. Which is just wild to think about.
Yeah, because by Western standards, you'd look at this behavior and immediately declare an absolute devastating epidemic of alcoholism.
Oh, absolutely. You'd expect total societal collapse.
Right. But what if I told you that in this specific culture, the concept of addiction literally does not exist?
That's fascinating.
There's no social dysfunction, no isolation, no health crises that are usually associated with that level of heavy drinking. So today on this deep dive, we are unpacking the vast and honestly incredibly complex machinery of addiction.
It really is complex, and it completely shatters the conventional narratives we're so used to hearing. I mean, when we look at the latest scientific, sociological, and psychological research, we have to completely throw out the idea that addiction is just, a moral failing or a simple lack of willpower.
Yeah, it's far more intricate than that.
Exactly. It's not just a bad habit.
Okay, let's unpack this. Because to make sense of a society that can binge drink without addiction, or to understand why a teenager gets hooked on a smartphone game, we have to completely reframe what addiction actually is.
We do.
The materials we're exploring today describe it as a profound neuropsychological phenomenon.
Yeah.
We're talking about the physical synapses in your brain being reshaped in ways that are, well, they're strikingly similar to what happens when you fall deeply in love.
Or even when you taste an incredibly delicious meal, right?
And to truly understand how that happens, we have to look at addiction as a biopsychosocial disorder.
I know that sounds like a massive clinical mouthful, but it simply means that addiction sits at the messy intersection of our biology, specifically the brain's reward system, our individual psychology, and our social environment.
So it's all connected.
Yeah, you really cannot separate the biological molecule from the cultural environment. They feed right into each other.
Right. But before we can even begin to understand how culture or environment plays into this,
Right.
we need to understand exactly what is happening inside the brain on a microscopic level.
The actual mechanics of it.
Exactly. And the research points to a very specific circuit in the brain called the mesocorticolimbic pathway.
Yeah, so think of the mesocorticolimbic pathway as the brain's ultimate tally counter for pleasure and survival.
Okay.
It connects a region deep in your brain that releases dopamine to the nucleus accumbens, and then all the way up to the prefrontal cortex. Now, people often think dopamine is just the pleasure chemical,
Right, like it's just pure euphoria.
Exactly. But it's really a learning and motivation signal.
Yeah.
When you do something essential for survival, like eating calorie-dense food or having a positive social interaction, your brain releases a spike of dopamine.
It's your brain's way of saying, like, that was good, remember exactly how you did that and do it again.
Spot on. But drugs of abuse completely hijack that natural tally counter. They flood that pathway with unnaturally massive, prolonged surges of dopamine.
And this is where we get to a microscopic culprit that absolutely blew my mind. There's a specific protein, a gene transcription factor called FOSB.
Yes, delta FOSB. And what is so fascinating here is that FOSB is basically a common denominator in the development of virtually all forms of addiction.
Wait, all forms?
Virtually all of them, yeah. When you are chronically exposed to an addictive stimulus, whether that's a chemical substance or even a behavior, this protein slowly begins to accumulate in the neurons of the nucleus accumbens.
So it builds up over time.
It does, and it literally goes in and alters your gene expression. It changes the physical architecture of your brain's reward center.
Wow. And it doesn't just wash out of your system after a good night's sleep, does it?
Mm-hmm.
The research highlights that while most proteins in the brain come and go pretty quickly, FOSB is incredibly stubborn.
Oh, it is exceptionally stable. It persists in those neurons for like 1 to 2 months, even after a person completely stops using the substance.
1 to 2 months.
Yeah, even with total abstinence.
Think of FOSB like a molecular light switch that gets jammed in the on position. Like you've left the room, you've locked the door, you have stopped the behavior entirely. But the lights are still glaring for months, screaming at your brain to seek out that reward.
That is a perfect way to visualize it.
Mm-hmm.
Because it stays there, it acts as a long-lasting biological memory. And as it accumulates, it actually represses other genes in the brain to ensure that even more FOSB can build up.
It's like a vicious cycle.
Exactly. And this accumulation directly drives a phenomenon that researchers call reward sensitization.
Let's clarify that for the listener, because it's so easy to confuse sensitization with tolerance.
Right, they aren't the same thing.
Yeah, tolerance is a concept most of us know, like you drink a cup of coffee every day, and eventually you need 2 cups to feel the same buzz. But sensitization is doing something entirely different to the brain.
It's a totally different mechanism. Reward sensitization is a pathological increase in what scientists term incentive salience.
Okay, incentive salience.
Yeah, which in plain English just means the wanting or craving for a reward. So over time, because of tolerance, a person might actually experience much less actual pleasureless liking from the drug.
So they don't even enjoy it as much.
Right. But because of the sensitization driven by FOSB, their craving, their desperate wanting of the drug and anything associated with it just skyrockets.
You don't even like the feeling anymore, but the compulsion to seek it out is stronger than ever.
Exactly.
Which brings up a huge question for me. If this hijacked wanting system happens with chemical drugs, what happens when we do naturally rewarding things? Like, can those natural dopamine spikes turn into the same kind of trap?
They absolutely can. And that bridges us right into behavioral addictions. The exact same biological pathways, complete with that stubborn buildup of FOSB, can be co-opted by everyday activities without a single drop of a chemical substance involved.
So things like scrolling on your phone, playing video games, shopping.
Exactly. Sexual behavior, gambling, gaming, they all activate this identical mesolimbic pathway.
That's wild.
And the medical community has formally caught up to this reality too. The DSM-5, which is, the primary manual for psychiatric diagnoses, now officially recognizes gambling as a severe behavioral addiction.
Right.
And the World Health Organization's ICD-11 recently recognized gaming addiction. Preclinical evidence shows that repetitive, extreme exposure to these natural rewards induces the exact same neuroplasticity as a drug addiction.
And the data dives heavily into something that I think will resonate with a lot of people listening. Food addiction.
Yes, that's a big word.
The research explains that highly palatable foods, things engineered to be high in fat, salt, and sugar, like a decadent chocolate cake or fast food trigger, the brain's reward system so violently that they can actually override the body's natural hormones that tell you when you're full.
They completely bypass your natural satiety signals. You develop a tolerance to the dopamine hit of the food, so you have to eat more of it to get that same feeling of comfort or reward, even as the food becomes less physically satisfying. To measure this, researchers at Yale developed the Yale Food Addiction Scale, or the YFAS. It's a questionnaire designed to assess signs of food addiction using the exact same diagnostic criteria used for substance use disorders.
Okay, I have to play devil's advocate and push back here for a second. We all need to eat to survive.
Sure.
And many of us look forward to a great piece of chocolate cake at the end of a long week. If you're listening to this and thinking, well, I love sugar, am I addicted? At what point does just really loving a dessert cross the line into a clinical pathology according to these scales?
That is the vital distinction to make. According to the YFAS, a potential food addiction diagnosis is predicted not just by how much you like the food.
Okay.
It requires the presence of multiple substance-related disorder criteria combined with a significant impairment to your daily life.
So it's about the collateral damage.
Precisely. It is the loss of control. It's continuing the behavior despite clear negative consequences, despite it actively harming your physical health, ruining your social life, or causing severe psychological distress.
Right, it's no longer just a treat.
Exactly. It's when the drive to consume becomes a compulsion that overrides your cognitive control, rather than just a source of enjoyment.
So it's that invisible line where the reward circuitry basically takes the steering wheel away from your rational brain.
Yes.
But this leads to an obvious puzzle. If we all experience natural rewards, and we all get these dopamine spikes from a great meal or winning a game, why do only some people develop an addiction?
That's the million-dollar question.
Right. Like, 2 people can experiment with the exact same behavior and only one gets hooked. What is the invisible tiebreaker?
Well, that brings us to the vulnerability factor. Why is one brain more susceptible than another? To answer that, we have to look at a combination of age, genetics, and epigenetics.
Let's start with age, because the statistics here are pretty sobering. Over 90% of those with an addiction began using substances or engaging in the addictive behavior before the age of 18. Why is that window so critical?
It basically comes down to an adolescent brain mismatch. During our teenage years, the limbic reward circuits, the older parts of the brain that seek out pleasure, novelty, and peer approval mature, well before the prefrontal cortex is fully developed.
So it's like installing a Ferrari engine inside a golf cart.
That is a terrifyingly accurate analogy.
The capacity for speed and intense reward is massive, but the steering wheel and the braking systems just haven't been built yet.
That is exactly what's happening biologically. The prefrontal cortex is the cognitive control center. It's the brain's brakes. Because of this developmental mismatch, the incentive reward system is granted disproportionate power over decision-making.
So they just can't say no as easily.
Right. It makes teenagers incredibly vulnerable to experimentation. And unfortunately, exposing the brain to massive dopamine surges during this early malleable period can disrupt how synapses are pruned.
Wow.
Yeah, it causes permanent alterations in how that brain processes rewards for the rest of their life.
That is heavy. And then there's the family tree, the genetic factors.
Yeah.
The research notes that genetics account for like 40 to 60% of the risk for severe substance disorders like alcoholism. But genetics isn't just about the DNA sequence you're born with, right? It's not a fixed destiny. It's also about how those genes are expressed.
Exactly, and this is the science of epigenetics. Epigenetics is the study of how environmental influences can change how your genes are read without altering the underlying DNA sequence itself.
Okay, so how does that work?
Think of your DNA as an enormous instruction manual. Epigenetics is like a highlighter pen that comes in and marks certain paragraphs to be read more often while completely crossing out other paragraphs.
I see.
Yeah, and chronic drug use or extreme environmental stress can cause these epigenetic changes, physically altering the reward signaling pathways.
Okay, here's where it gets really interesting. There is an animal study detailed in the research on transgenerational epigenetic inheritance that it stopped me in my tracks.
It is a groundbreaking study. Researchers took male rats and exposed them to cocaine. Now, as a result of this exposure, these specific rats developed epigenetic alterations, specifically an increased expression of a gene called BDNF in their prefrontal cortex.
Okay, and what did that do?
What this did, remarkably, was blunt the rewarding properties of the cocaine.
Wait, so the exposure essentially triggered an internal biological defense mechanism. It made them want the drug less.
Exactly.
Wow.
But the truly profound part of the study wasn't just what happened to those fathers. It was that they passed this exact epigenetic alteration onto their male offspring.
You're kidding.
No. The fathers transmitted an epigenetic resistance to cocaine addiction to a generation that hadn't even been born yet.
Wait, hold on. Just thinking about the gravity of that. The father's drug use didn't just hurt him. It literally built a biological shield inside his son.
That's what the data shows.
That completely rewrites how we think about generational trauma and biology. But it also raises a massive question for me. If our environment, or our parents' environment, can alter our gene expression that profoundly, what role does a stressful society play in triggering these vulnerabilities?
That is the crucial pivot we have to make here. The brain disease model we've been discussing focuses heavily on biology, but the environmental canvas dictates whether those biological vulnerabilities are ever triggered in the first place.
Right.
Chronic stress, adverse childhood experiences, systemic poverty, these environments profoundly dysregulate the nervous system. They drastically increase the motivational value of any substance or behavior that can temporarily reduce those negative feelings.
Which pulls the camera all the way back from the microscopic molecule to the macroscopic society. There's a framework the researchers call the critical medical anthropology model.
Yes.
It argues that we shouldn't just look at addiction as a brain disease, but as a form of self-medication against the social production of suffering.
Exactly.
It points to political disparity, institutional power, and marginalization as the root causes of the psychological trauma that people are desperately trying to soothe.
We see this vividly illustrated in what anthropologists call the subcultural model. There was an incredible ethnographic study from 1969 by Edward Preble and John J. Casey.
Oh, the New York study.
Yes. They spent time documenting street-based intravenous heroin users in New York City. And what they found challenged the dominant narrative of the time, which viewed these individuals merely as immoral dropouts trying to escape reality.
Right. The researchers found the exact opposite. For these heavily marginalized individuals, the intense daily hustle surrounding their drug use actually provided a highly structured social connection.
It did.
It gave them a symbolic meaning and a socially constructed purpose that felt completely unattainable to them in conventional mainstream society.
The drug subculture, ironically, provided a community and a sense of identity where society had offered them none.
It provided a place to belong. Which is heartbreaking, but it makes total mechanical sense when you look at humans as deeply social creatures.
Absolutely.
But this leads perfectly back to the scenario I mentioned at the very beginning of our deep dive, the society that drinks heavily without addiction.
Yes, you are referring to the work of anthropologist Dwight Heath. He developed the cultural model based on his extensive field work in the 1950s with the Kamba people of Bolivia.
So what exactly did he observe there? Because it sounds completely counterintuitive to everything we know about alcohol.
Heath observed that adult members of the Kamba Society drank massive quantities of an 89-proof rum during their social festivals.
Right.
They would drink to the point of severe intoxication, often passing out for several days at a time, at least twice a month.
So what does this all mean? By our standards, their biological reward centers are being absolutely flooded with dopamine and FOSB.
Undeniably.
But Heath observed that they had no concept of alcoholism. More importantly, they showed absolutely none of the aggression, the social isolation, or the cascading health crises that we associate with that level of drinking.
None of it.
Are you saying that without the cultural stigma or the extreme social isolation that usually accompanies addiction in the West, the disease itself doesn't manifest the same way?
It forces us to heavily consider that conclusion. Heath's findings propose that the severe problems associated with heavy substance use are largely determined by cultural beliefs and social context.
Wow.
For the Kamba, this habitual heavy consumption was not an isolated, shameful act. It was a highly valued communal ritual that actively enforced their social bonds. There was no marginalization attached to it.
That changes everything.
Right. Now, this doesn't erase the biology of FOSB, but it forcefully reminds us that the psychosocial environment can entirely dictate the consequences and the human experience of the behavior.
It's the biopsychosocial model perfectly illustrated. The molecule matters, but the culture decides how the molecule expresses itself. And understanding that delicate interplay between the microscopic biology and the macroscopic social elements is exactly what is driving modern innovations in treatment. Because if you know how the machine works on every level, you can intervene on every level.
And the recent medical advancements we are seeing are nothing short of revolutionary. We're moving far beyond just talk therapy and into highly targeted biological interventions. For instance, the development of addiction vaccines.
Vaccines. Like we used to train the body to fight off the flu, but for a drug. How on earth does the immune system fight a chemical?
The mechanism is brilliant. The theory is to train the immune system to recognize and attack drug molecules before they can ever reach the brain.
Okay, how?
Well, for example, there's a vaccine in clinical trials called TACD for cocaine. It works by combining a cocaine derivative with a harmless, inactivated cholera toxin.
Oh.
This large combined molecule stimulates the patient's immune system to produce targeted antibodies. If the person then uses cocaine, these newly minted antibodies immediately bind to the cocaine molecules right in the bloodstream.
And because they are bound together, the molecule becomes physically too large to cross the blood-brain barrier.
Exactly. It intercepts the drug. The drug never reaches the nucleus accumbens, the dopamine release never happens, and the euphoric high is completely negated.
That is wild.
There is also a similar one called NicVX for nicotine. Now, these vaccines do not instantly stop the psychological desire for the drug, but they physically break the biological reward cycle, giving the person a crucial window to recover.
And beyond vaccines, there is a massive breakthrough discussed in the literature involving GLP-1 agonists. If you follow health news, these are the medications currently sweeping the world for diabetes and weight management drugs, like semaglutide, which most people know as Ozempic.
Yeah, they've become culturally ubiquitous for weight loss, but their potential for treating addiction is staggering. A recent massive study in the journal Addiction analyzed the health records of over 1.3 million individuals.
And what did they find regarding substance use for the people on these weight loss drugs?
They found that individuals actively using Ozempic or similar GLP-1 medications had a 40% lower risk of an opioid overdose and a 50% lower risk of severe alcohol intoxication compared to those not using the drugs.
Wait, how is a stomach medication doing that to opioid and alcohol cravings?
Because it's not just a stomach medication. GLP-1 receptors don't just exist in the gut. They exist in the brain's reward centers.
Oh, wow.
Yeah. These medications effectively quiet the food noise in the brain that drives compulsive eating, and researchers are realizing that the exact same biological volume knob that controls food noise also controls drink noise and drug noise.
That makes so much sense.
By dampening the hypersensitized reward pathways, these drugs seem to dramatically reduce the compulsion to consume across the board.
That is incredible. A pill that could potentially lower the volume on that jammed Hospi light switch.
Right.
But, as we've established today, fixing the biology is only half the battle. If someone is self-medicating for severe trauma or social isolation, you can't just prescribe a pill and send them back into a broken environment.
No, you absolutely cannot.
You have to heal the psyche, too.
Mm-hmm.
And the research highlights some fascinating ways art is being used to do exactly that, not just as a therapeutic hobby, but as a serious clinical assessment tool.
Yes, like the Formal Elements Art Therapy Scale, or FEATS. Clinicians use it to evaluate drawings created by individuals struggling with substance use disorders.
Yeah, so they analyze the art itself.
Exactly. Rather than just asking a patient how they feel, which can be incredibly difficult for someone processing trauma, the clinician looks at the structural elements of their artwork. They look at the realism of the human features drawn, the overall complexity of the image, and the developmental age reflected in the drawing style.
It allows healthcare providers to chronify these abstract, visceral emotions that the patient simply doesn't have the words for yet.
Yes.
There's also an assessment called the bird's nest drawing.
Oh, that is a particularly insightful tool. The therapist asks the client to draw a bird's nest. Subconsciously, the nest represents the home and the family dynamic.
That's beautiful.
And the therapist analyzes the drawing to visualize the client's attachment security. For instance, the amount of color used can indicate how secure or insecure they feel in their interpersonal relationships. A stark lack of color or a chaotic structure often points to an insecure attachment style.
And knowing that attachment style is a massive piece of the puzzle for a therapist trying to build a stable recovery framework for that specific person.
It's crucial.
But beyond the clinical assessments, art is being used powerfully to fight the social stigma we talked about earlier. The dossier mentions a project at Temple University and another grassroots initiative called Voice, where women with histories of severe addiction created art to document their lives.
If we connect this to the bigger picture, the goal of these advocacy projects is to put a profoundly human face on a condition that is too often reduced to statistics. By showcasing the emotional depth and humanity of these individuals, the art helps shift public perception. It forces society to stop viewing addiction as a moral failing of bad people and to start viewing it as a chronic, highly complex medical condition that requires empathy and structural support.
Because treating addiction truly requires this multi-pronged approach. You need the biological interventions, like the potential vaccines or the GLP-1 medications, to quiet the physical cravings and give the brain a chance to breathe.
Right.
But you absolutely must combine them with psychosocial healing through therapy, art, and ultimately rebuilding a sense of community connection.
It is the only way to treat a biopsychosocial disorder. You treat the biology, the psychology, and the society.
It's been an incredible journey we've taken today. From the stubborn, invisible persistence of that jammed molecular switch, FOSB, lurking in our neurons,
to the protective epigenetic armor passed down by those rat fathers.
Yeah, that was wild. And to the stark realization that human connection and culture, like with the Kamba people, can completely dictate how a vulnerability manifests. And finally, the wild promise of immune vaccines and volume-lowering medications.
It is a powerful reminder that human behavior is never a simple binary of good choices versus bad choices. It is deeply complex, beautifully intricate, and intensely vulnerable to the world around us.
It really is. And I want to leave you, the listener, with one final fascinating thought from the research that we haven't touched on yet. It's about the origin of the word itself. The word addiction comes from the ancient Latin root addico.
This is a perfect place to end because that Latin root has a very revealing dual meaning.
It does. In ancient Roman law, addico meant being enslaved to a creditor, literally giving up your freedom and your body to pay a massive debt.
Which is a bleak but perfect description of the loss of control we've discussed today.
Right, but the word also meant devotion. It meant dedicating yourself entirely, giving yourself over to something profoundly good.
That's amazing.
It was only much later, during the temperance movements of the 19th century, that society stripped away the second meaning and narrowed the definition solely to disease and enslavement.
It forces us to look at the underlying machinery we've been discussing in a totally different light.
Exactly. We started this deep dive talking about how the brain's synapses reshape during addiction in ways that are strikingly similar to falling in love.
We did.
So we leave you to ponder this. Is it possible that the incredibly powerful machinery of addiction is actually just our beautiful, natural human capacity for deep devotion? Is it a feature of our biology, not a bug, that has tragically been captured by the wrong stimuli in a modern, isolating world?
It is a profound reframing of the human condition.
Something to think about the next time you find yourself wanting something a little too much. Until next time, keep digging deep.